Let's talk about distribution transformers. There's a couple ways to hook them up. You can either go delta or Y. Now delta's hooked like this, where the coils are tied end to end like this, and Y connection, one leg of each coil is all tied together, and that's brought out as a neutral here. So that's our Y connection. On the delta, we center tap one of the coils, and that brings out our neutral, and the neutral is our grounded conductor. It's grounded at one place coming into the building. So light industry, they'll use a hookup like this, where they'll have 3 transformers up on a pole, and they'll have out here they'll have 240 volts between phases. These are black, red, and blue, and we can use that to run 3-phase motors and that. And then we center tap one of the coils here, and that brings out our neutral, and so we have 120 volts from phase A to ground or neutral, and phase C to neutral there, and then 240 volts across there. So this is for motor loads, and this is for your lighting and small appliance load here. And you can hook them up delta-wye. Now delta-wye, a lot of times we'll go with higher voltage. We'll go 480 volts between phases, so you have 3-phase 480 volts, and they'll use that for motor load. Now, when you do that, they'll bring out this neutral wire here, and between phases and neutral you get 277 volts. Now, they'll use that for lighting loads in these buildings for fluorescent lighting. Nowadays it's mostly LED lighting, but they'll use 277 volts for your lighting. You have all 3 phases of those. Now, in this Y connection, the voltage across the coil here, in this case, it's going to be 277 volts. If you times that by the square root of 3, or 1.73, you get your voltage from phase to phase here. So at 277, you're going to get 480 volts here. Now, another way to hook this up is to go with 208 volts here between phases. So you have 3-phase 208, and you can actually run motors off of that. But over here, you're going to have 120 volts to neutral, and in all 3 phases, A, B, and C, and that's going to be black, red, and blue, and white for the neutral there. So that gives you more 120 volts for your small appliance load in that, and then it gives you some load for your motors and stuff, but running at 208 volts. Okay. Now, so they use those for industrial buildings, not 3-phase and the single phase like that. But for residential use, they'll have 1 transformer on the pole, and this is what it looks like outside of my place here. We have 3 lines coming overhead, and they happen to be 4160. It goes into it's called a 2-bushing transformer, and 2-wire primary. And it's a residential transformer. See these round pots up on top of the telephone pole. Now, what they'll do here is they have the transformers connected this way, and we have black, white, and red here. We have our 2 phases here, and our neutral tapped off the center here, and that's going to ground. So that gives us 120 volts from phase to ground, and phase to ground here, 120 volts. Now, those two they're actually 180 degrees out of phase with each other coming in here. And we have 240 volts between phases here. Of course, that's just a single sine wave. It's single phase. So we call this our single phase. And this is what we use in a residence. So we can use our 240 volts for our ovens and our electric dryers and that, and then the 110 volt for small appliances and lighting load. So this is what most residents have. And these are used for more industrial areas. So what we're going to do is we're going to take a look at the oscilloscope. I'm going to show you that these two are 180 degrees out of phase with each other. But then if we go from phase to phase here, the 240 volts, it's a single phase. Okay, we'll look at the scope on that. Now, if you're trying this or you're hooking up a scope, this, first of all, my scope is only good for about 24 volts, so I got to use a voltage divider. But this neutral wire, it's grounded. It's grounded at the entrance of the building, okay? Now, you can have potential from neutral to ground somewhere else in the building if you're, say 100 feet or so away from that first grounding point there. It's only grounded in one spot, okay? But if you tie this lead on your scope is actually grounded. It's grounded to this back to this neutral, back at the beginning of the building through the scope. And so if you put your ground on here and a probe on one of these, you're going to probably be all right. Now, if we go from line to line here, though, and you try to put this conductor here, which is grounded on one of these lines, that's going to be a dead short, okay? Now, hopefully the worst thing that happens is this wire is going to burn off before the fuse gives out on this thing. So, yeah, not good. It's dangerous, and it could wreck your scope here. So don't be putting your scope across this 240 volt phase here. So in order to do that, I'm using a isolation transformer, or a couple isolation transformers. So I won't show you how I'm doing that, but we'll go over to the scope and show you what these waveforms look like. But so probing 100 and this high voltage stuff, just be very careful with that, and you can damage your equipment or yourself with that. So you need to be careful. Anyway, we'll head over to the scope. All right, here we are at the scope. That's our phase to neutral. So that's 120 volts there. And that's one phase. Here's the other one. So now, if I drag these together, you can see that they're 180 degrees apart. So from phase to neutral, each phase they're 180 degrees apart from each other. Then I'm going to hook up the get rid of one of these and just tie my scope around off both of them. Oops. I don't want that. Almost wrecked it. Let's try that. All right. Yeah, be careful with this. There we go. Let's get rid of that one. And that's our 240 volts there. So yeah, be careful when you're probing this stuff. Anyway, that's the two phases, 120 volt phase. They're both 180 degrees out of phase, but the 240's just a single phase. So that's it. Thank you.